Welcome to the video explaining how to do questions 1 through 4 on the example exam. This one will go through pressure vessels, the polar moment of inertia, and stress due to torsion. We are given a tank with an inner diameter of 180 inches and a thickness of 0.2 inches and an internal pressure of 0.1 ksi, and we are asked what is the hoop stress. And we know the hoop stress, we have an equation for that. It is P times R over the thickness, which in this case is going to equal our pressure 0.1 kips per square inch times our internal radius. In that case, that will be 90 inches, which is half the diameter there. Assume you can do that on your own. And then divided by 0.2 inches, that's the thickness of the tank. All this together gives us 45 ksi is the stress in, well, let's just draw a square element there. 45 ksi of tension is going to be the stress in this direction, resulting from the pressure within. Next, we're asked about the longitudinal stress, the stress in this direction. In that case, we use the equation of the longitudinal stress. Well, we can use this one. We can use that it is P times the inner radius divided by 2 times the thickness. We could also use that it's equal to 1/2 the hoop stress. And that's what I would use here, because that means we've got 1/2 45 ksi, which is 22.5 ksi. So that's going to be the stress in this direction right here from the pressure. And there's also a torque applied. You can see that torque right there, it's drawn right there. The question for number 3 is, what is the polar moment of inertia, J, for the tank? Now, our equation for our polar moment of inertia, J, is, of course, pi over 2 times the outer radius, which I guess we're calling rho in usually, to the 4th minus the inner radius also to the 4th, which in this case will be pi over 2 times the outer radius will be 90.2 inches to the 4th, of course, minus our inner radius, which will just be 90 inches to the 4th. And when we punch everything in there, we're going to get 919,146.6 inches to the fourth. It's really not necessary to get all the way to 0.6 with this, I think, but it's fine. So now we are asked, what is the torque, what is the shear stress induced by this torque? The torque, or the shear stress induced from the torsion is 25 kSI. And we're asked, what is the torque to induce that? Well, in that case, we're going to want to use our torsion stress equation, but we're going to rearrange it. We're going to go from it being the shear stress for torsion is equal to the torque applied times the distance from the center divided by our polar moment of inertia. We'll just rearrange that to obtain that the torque is equal to shear stress times our polar moment divided by our radius. And this is going to be 25 KSI times our polar moment of inertia is this big old number here, 919,147, really, inches to the fourth, divided by our radius, and our radius in this case is going to be 90 inches, 0.2, right, plus the thickness of the plate, or the pressure vessel, I should say, and that's going to end up equaling quite a number. It's a large tank. 254,752. Now let's give it a decimal place. 2.4 kip inches. So that's the answer to the first 4 problems on the practice exam. Let's move on to 5.